Okay, here's the review problems for test 13, which goes through lesson 44. First of all, we have an angular velocity problem. So that's going to use the formula V equals RW, or omega. V is the linear, and the omega is the angular. So this particular problem wants the velocity in miles per hour, which is the linear, so we're going to use the formula as it is, which means we should take the radius, 16 centimeters, and multiply it by the angular velocity, which is 40 revolutions per second. And then we're going to put in some more conversion factors to reconcile our units. So first of all, I need to get rid of the revolutions, and it's been a while since we've had a problem that did that, but if you have revolutions to start with or you are asked for revolutions, either one, you're going to need the conversion factor that has 1 revolution equal to 2 pi radians, somewhere in there, and you set it up, in this case with the revolutions on the bottom. If you're asked for revolutions, you would have 1 revolution over 2 pi radians. Okay, then looking at the kind of units that I need in my answer, I need miles, and right now I have centimeters. So I will go from centimeters to inches. That'll cancel out the centimeters unit. Then I can go from inches to feet, and then from feet to mile. Inches cancels, feet cancels, and I'll be left with miles. The other unit that I need in my answer is hours. Right now I have seconds, so I need a conversion factor that goes from seconds to minutes, with seconds on the top to cancel out the seconds on the bottom, and then from minutes to hours. And then the question on the test just has you leave it as a big fraction, kind of like we've been seeing in the answer key. So all my numbers on the top are 16, 40, 2 pi, and 60, 60. And then along the bottom, I've got 2.54, 12, and 5280. And on the test, they want you to just leave it like that. For number 12, we are looking at an equation for a parabola, and it'll say that it's a parabola on the test. It wants you to complete the square to graph it. So for the parabola, it's a little bit different than the circle because you're only going to have 1 parenthesis where you're completing the square, and that's with the x squared components, the x and the x squared. We're actually going to rearrange whatever equation we're given so that we've got y on a side by itself and everything else over on the left. I've got a sign wrong. Okay, now we're going to isolate the x terms in parentheses, and I need the x squared to not have a coefficient, so I'm going to factor out its coefficient of 2. Also factor it out of the x term, leave some space, and then we got our minus 7 at the end, which I'm not factoring the 2 out of because it's not in the parentheses. The b inside the parentheses would be the negative 2. Half of that is negative 1, and then we square it to get positive 1 that we add inside. And then we need to subtract it on the outside to balance that out. But instead of subtracting just 1, I'm going to subtract 2 times 1, the number outside the parentheses times the number inside that I added. Okay, and then we're going to simplify this down. The parentheses goes down to x with the half of b, which was the minus 1. And then outside here, I've got negative 7 minus 2, so it'd be a negative 9. So I'll be able to graph this parabola with a vertex over at 1, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be upward facing and a little bit skinnier than it might have been otherwise, with a vertex at 1, negative 9. All right, for the area of a triangle on this test, you're going to have to convert the units. So on this particular problem, I'm given meters and they want centimeters. So I'll multiply each of these numbers by 100 before I start. All right, and then we're looking for our area of a triangle formula, which is 1/2 base times height. But the height in this case is going to be the slanted side times the sine of the angle. That's what I'll be plugging in for height. My base is the other side, 25. And I'll plug that into my calculator. And I get about 541 centimeters squared. For number 23, I've got cosine squared and a cosine, so I'm going to factor out a cosine from each of those terms. And that would leave in a parentheses 1 cosine left in the first term and just the 1/2 or minus 1/2 left for the second term. Then I'm going to take each of these factors and set them equal to 0. And solve for cosine. And then look at each and solve for theta separately. So on the left, we've got cosine theta equals 0. So where does cosine equal 0? Well, that would be one of the, or a couple of the 4 quadrantal angles. Cosine is the x value, so that would be up here at 90 and down at 270. For the one on the right, cosine theta equals 1/2. That would be a special triangle. The triangle that has sides 1 and 2 would be the 30-60 triangle, adjacent over hypotenuse, and the angle that's adjacent to the 1 is the 60-degree angle. I would have one more answer in the other quadrant where cosine's positive, which is the 4th quadrant. So 60-degree angle in the 4th quadrant would be 300 degrees. Number 17 is area of a segment. So on a circle, I draw my little pie piece. The segment is just this pie crust area, where a sector would be the whole pie piece. So to find the area of a segment, it would be equal to the area of the sector, or the whole pie piece, minus the area of the triangle that I've made by drawing that line. Okay. All right, so let's mark some of the numbers here. We've got an angle of 130 degrees, which I've drawn it much smaller than that, but that's okay. And then a radius of 0.3 meters. They want the answer in centimeters, so I'll go ahead and change that to 30 centimeters. Okay, so the area of the sector is the area of the circle times the degree that you're given over the entire circle's worth of degrees. So in this case, they're actually giving me degrees, not radians, so I'll have my 130 degrees over 360. If they gave me radians, I would put the radians they give me over 2 pi. All right, so then I've got pi times 30 squared times the degrees that I'm given over a full circle. And I'll put that in my calculator and get an answer. I got about 1021.017, so about 1021. Then the area of the triangle so this triangle has 2 different sides that measure the 30 centimeters because 2 of the sides are the radius. So I can use a similar triangle formula that I just used before. 1/2 times the base, which is one of the sides, times the other side times the sine of the angle. I'll put that in my calculator and get 344.7. And now I have my 2 numbers, the area of the sector 1021 minus the area of the triangle, 344. And I'm going to get an answer of about 676.3 square centimeters. All right, here they want us to use the locus definition. Don't worry about that wording. You guys get thrown off by that, but just focus on what they're asking you for. An equation of a perpendicular bisector. So we're going to end up with a y equals mx plus b kind of answer. So to do that, we need, number one, a perpendicular slope to the points that are given. So I'm going to find the slope between the 2 points that are given by doing y minus y over x minus x. And I get a slope between those 2 points of 1/5. That would make my perpendicular slope -5. Second, this is a bisector, which means I need a midpoint, a halfway point between those two end points. So to find my midpoint, I would be taking the average of the x's, so add and divide by 2, and the average of the y's, add and divide by 2, and that will get me, let's see, 2 over 2 is 1, and 14 over 2 is 7. So my midpoint is 1, 7. And that'll set me up for my final step, where I'll take the point slope form, plug in the perpendicular slope that I found, and the point that I found for y1 and x1. And I come out with y equals -5x plus 12. All right, the first one on this slide has the cost of doing business varies linearly. So varying linearly means on a graph it would be a straight line, and straight lines are represented with the y equals mx plus b. So you're going to use the first set of numbers, the first two pairs of numbers, I guess, to come up with a slope. So I've got a slope of y minus y over x minus x. I get a slope of 20. Then I can take that slope and use either one of the two pairs of points along with that slope you just found in this point slope formula. So I'll use the 40 hours, cost is 1,200. The cost is our y value, 1,200. The slope that we just found is 20. And the number of hours that went with it is 40. And I will solve for y, so I have my y equals mx plus b. Add 1,200 to both sides. And there's my equation. The last step is to look at your new hours that we haven't been using yet, the 30 hours a week, plug it in for x, and find the cost that's associated with it. And I get a cost of $1,000. All right, number 7, distinguishable permutations. I have the word permute. Didn't know that was a word. It's got 1, 2, 3, 4, 5, 6, 7 letters. So the permutation would be 7 factorial divided by the identical letters. So the identical letter I have here is 2 e's. So I'll have 2 factorial in the denominator. None of the other letters are repeated, but if you had more types of letters that were repeated, you would add their factorials in the denominator as well. And then I'll have 7 factorial divided by 2 factorial, which comes out to 2,520. All right, here we're multiplying the polar forms of these imaginary numbers. To multiply, we multiply the coefficients. 6 times 3 makes 18. And add the angles. Negative 30 plus 90 makes 60. And I'm going to expand this. CIS notation means cosine of the angle plus imaginary number times the sine of the angle. And you need to give an exact answer, which means you're drawing a special triangle to come up with the cosine and sine, rather than putting it in your calculator, which might round, especially if it involves a root. So I'm going to draw my 30-60 triangle, label the sides. The cosine of 60 would be adjacent over hypotenuse, which is 1/2. The sine is opposite over hypotenuse, so √3/2. Then distribute the 18 to each of those. So 18 times 1/2 is 9. 18 times √3/2, the 2 would cancel the 18 down to 9 as well. So I'd have 9√3i. All right, here we have a summation problem and sets of numbers for x and y. So we'll be looking at the first x term, second x term, third x term, etc. Same for the y's. All right, so on this summation, they want the first x term, the first times the first y term squared, and then the second one, I'm supposed to have the second x term, 1 plus 1, and whatever that is, square it. All right, so that's going to come out to 3 times 0 squared minus negative 1 squared. And all that comes out to 1. All right, then I'm going to do the same thing for 2 and 3. I'm going to pause the video and work that out. All right, so I have everything plugged in. I also noticed on the first term that I should have had negative 1. And then in the middle section, I plugged my numbers in, and they're going to come out to negative 4. And then in the last section, I have 0 minus 2 squared, so that's also negative 4. Add these three together, and my final answer is negative 9. All right, here's our last review problem with the logarithms, where you have logarithms in the exponent, which we had on the previous test, but these need a little bit of work. They're not ready to just cancel. So the logarithms in the exponent, it needs to be one logarithm, no coefficients. So in this first exponent, the 2 coefficient needs to be moved to make it an exponent of 3. So we'll end up with a 9 there. In the second exponent, the exponent for 8, I'm going to combine these 2 logs together by dividing the arguments. 6 divided by 3, which makes a 2. Now that each exponent is a single log with no coefficient, it can cancel with the base, and you're just left with the argument. 9 plus 2 equals 11.